When we look at the night sky, it feels like we are seeing the whole picture. But the math tells a different story. 85% of all matter in the universe is completely missing from our sight and our instruments. For centuries, astronomers operated on the assumption that what you see is what you get. If a galaxy glowed brightly, we believed we were seeing the entirety of its mass. We calculated a galaxy's gravitational pull simply by measuring the light emitted by its stars, planets, and glowing gas. The more light we saw, the more gravity we expected. That trust in our own eyes has turned out to be a mistake. Modern astrophysics has proven that the light we see represents only a tiny fraction of what is actually there. The tension surfaced when we measured the speed of stars at the outer edges of spiral galaxies. They were moving much faster than our equations predicted. Based on visible mass alone, there isn't enough gravity to tether fast-orbiting outer stars. Physics dictates they should be flung into the void. Instead, they remain locked in stable orbits, as if held by an enormous invisible halo. Astronomers now face two difficult options. Either our formulas for gravity fail when applied to the scale of a galaxy, or the majority of the universe is made of an invisible substance we cannot detect. Physicists call this missing mass dark matter. It is the placeholder term invented to balance the broken math and provide the necessary gravity. We define it by what it doesn't do. It does not emit, reflect, or absorb light across any known spectrum. Its only known property is its ability to silently exert a massive gravitational pull on the normal matter around it. Because we can't see it, we search for gravitational footprints to map where this invisible mass pulls across the cosmos. We see its influence in the Great Attractor, a massive concentration of mass hidden behind the Milky Way that pulls entire galaxy clusters toward the Norma and Hydra Centaurus regions. These invisible pools act as cosmic rivers, guiding the flow of visible galaxies across hundreds of millions of light years. It is a strange irony. We can map the exact shape and flow of this substance by watching how it bends reality, yet we have no idea what it actually is. If we can map this invisible framework with such confidence, what is it actually made of? The leading theory involves WIMPs, weakly interacting massive particles. These are hypothetical particles that would pass through normal matter as if it weren't there. To find them, we built massive underground labs like this one, shielding detectors under kilometers of rock and heavy piping to block out cosmic rays. Despite decades of searching and billions of dollars in investment, we have zero direct physical evidence that WIMPs exist. This lack of evidence has brought a controversial counter-theory back to the table: modified gravity. This idea suggests there is no missing particle at all. Instead, the premise is that the gravitational formulas we inherited from Newton and Einstein contain errors that only appear at the scale of a galaxy. Modern astronomy is caught between two paths. We either continue to hunt for a phantom particle that refuses to appear, or we accept that our mathematical understanding of the universe requires a complete rewrite. We have successfully charted the invisible scaffolding that dictates the shape of the cosmos. But even with that map in hand, its identity remains the largest unsolved problem in astronomy. We naturally assume that normal matter, the atoms that make up our bodies, our planets, and our sun, is the default state of reality. The math tells us otherwise. Normal matter is merely a 15% outlier in the grand arithmetic of the universe. Humanity exists as a collection of visible debris, drifting through the currents of a vast, invisible ocean that dictates our movement, while remaining entirely out of reach. We can perfectly map where the universe is, but the fact that we don't know what it is remains the most haunting mystery in science.